So, have you ever really stopped to wonder what the world looks like from inside an AI's mind? I'm not talking about what a camera sees, but how it actually perceives and processes information. Today, we're going to dive into some absolutely fascinating research that shows how the very way you show an AI a problem completely changes its ability to think. It's pretty wild.
Okay, so here's our game plan. First, we'll look at the ultimate test for an AI's real intelligence. Then we'll get into the weeds with the actual puzzles that are so tricky for them. After that, we'll explore the two different worlds of AI perception, seeing versus reading. We'll break down the clever experiment the researchers set up, check out the surprising results, and finally unpack why this changes, well, pretty much everything.
This is one of the biggest questions, maybe the biggest question in AI research today. How do you actually test for genuine, flexible intelligence? We need to get past just testing if a model can remember something it's already seen. We're talking about measuring something that looks a lot more like real, abstract thought.
And that brings us to this key concept, systematic generalization. It sounds a little academic, but the idea is simple. Think about it like this. It's the difference between a kid who just memorizes that 5 times 5 is 25 and a kid who actually understands the concept of multiplication. That ability to get the underlying rule and then use it on totally new problems, that's the holy grail.
All right, let's get into our first section, the ultimate AI test. And we're going to be talking about something called the ARC-AGI benchmark. Basically, researchers needed a tool specifically designed to measure this kind of flexible, generalizing intelligence. And this is what they came up with.
Now, what's so cool about these puzzles is that if you looked at one, you'd think, oh, that's easy. It's like a simple little logic game. And for human, it is. But for an AI, they are incredibly difficult. And that's because there's no way to cheat. You can't just use brute force or search a giant database for the answer. The AI has to actually infer the abstract rule from just a handful of examples.
Which brings us to our next section. Let's take a closer look at these puzzles. What is it exactly that makes them such a unique and powerful challenge for even the most advanced AI? So here's how it works. The AI gets a few pairs of grids, a before and an after. Its one and only job is to figure out the hidden rule that changes the input into the output. Now, these rules can be anything: detecting objects, using symmetry, copying patterns, and the real twist is that these simple rules are often combined in totally new ways the AI has never encountered. It's a pure test of reasoning from the ground up.
And now for section 3, where things get really, really interesting. Seeing versus reading. Because when an AI fails one of these puzzles, the reason it fails tells us something profound about how it perceives the world. This is really the heart of the research.
And this is the central mystery, the big question the researchers set out to solve. Is the AI failing because it just can't figure out the logic? A failure of its reasoning abilities? Or is the problem more fundamental? Is it failing because it can't even see the puzzle correctly to begin with? Is it a failure of perception? See, there are basically two ways to show an AI the puzzle. You can show it as an image, which is great because it gets the whole 2D layout at once, it can see shapes and relationships, but the downside is the details can get a little fuzzy. The other way is to feed it the puzzle as text, like a list of coordinates for each colored square. That's super precise, but it's a huge burden. The AI has to reconstruct a 2D world from a flat, 1D list of text. And this quote from the paper just nails it. When you flatten a 2D puzzle into a 1D sequence of text, you're forcing the AI's attention mechanism to do all this extra work just to figure out what's next to what, or what's above something else. It's stuff that we humans just see instantly. So let's move on to the experiment itself. How did they test this? This is where the researchers got really clever, figuring out a way to isolate the AI's sight from its thought. The method was just brilliant in its simplicity. They took a single puzzle and created 9 different versions of it. Some were images, some were various styles of text. Then they simply asked the AI the same question for each one. Hey, describe in detail what you see here. That's it. They then compared its description to what was actually in the puzzle and gave each format a perception score. Okay, so what happened? Let's get to the results, because this is where we see just how differently these AIs perceive the world. It turns out that the text-based and image-based approaches have totally different, almost opposite, blind spots. So the AI that read the puzzle as text, it was fantastic with specifics, like nailing exact coordinates, but it had what the researchers called 1D tunnel vision. It was reading line by line, so it would completely miss vertical patterns that are just screamingly obvious to us. It was literally missing the bigger picture. And then you've got the flip side. The AI that saw the puzzle as an image was great at getting the overall gist, the main shapes. But its vision was kind of blurry. It had this problem called visual aliasing, where the way it chunks images into patches meant it would just get the details wrong, like mistaking a single pixel for a whole 2x2 block. And just look at the raw data here. It's kind of crazy. For the very same puzzle, the perception scores are all over the map. A really structured text format like JSON, perfect score, 100%. It saw everything. But a simple row-by-row text file, barely over 60. And the image formats, yikes. One of them scored less than 50%. It got more wrong than right. So this brings us to our final and most important section, why this changes everything. If no single way of looking at a problem is perfect, if each way has its own unique blind spots, what's the solution? Well, it's actually pretty intuitive. You give the AI a second opinion. And this chart is the big reveal. This shows how well the AI actually solved the puzzle. By themselves, both the text and image formats kind of hovered around a 50-50 shot. But when they let the AI see the puzzle in both formats at once, letting it cross-reference the precise text with the big picture image, its performance shot up dramatically. And let that sink in for a minute. Just by picking the best format for the puzzle, giving it the right lens to look through, the AI got an immediate 8-point jump in how accurately it could even see the puzzle's features. That's a huge win before it even starts to reason about the solution. But this is the real kicker. By combining the two views, the text and the image, the quality of the AI's final answer improved by a factor of 0.20. That is a massive leap in problem-solving ability. And get this, they did it without changing the AI model at all. They didn't make the brain smarter, they just gave it a better pair of eyes. Which leads us to this really powerful conclusion from the paper. How we represent information to an AI, it's not just some minor formatting detail you figure out at the end. It is a first-order design choice. It's one of the most fundamental, most important decisions you can make. And that leaves us with this final, kind of mind-bending thought. This whole study was about vision, but it proves a much bigger point. Perception shapes reasoning. So if just giving an AI two different ways to see can make it that much smarter, what happens when we start teaching AIs how to hear, to touch, or to understand context the way we do? The future of AI might not just be about building bigger brains, it might be about giving them richer senses.